Alright, sixth graders, we're going to start chapter 10, and the first lesson is about rational numbers. Rational numbers. Some numbers are rational numbers. What's the opposite of rational numbers?
Irrational.
Irrational numbers, yep. Irrational numbers are numbers like the number for pi. Okay? Pi is the number we use in a circle. It's the ratio between the diameter of the circle and its circumference. Okay? Or I should say its circumference to its diameter. But it's like 3.1415, something like that. It goes on and on and on in a random order, and it never ends. That's an irrational number because it's random at the end and it never ends. Okay? But rational numbers can be written as a fraction. So here's some examples of rational numbers. That's what we're going to spend most of our time talking about. An integer. What's an integer again? Brett?
A number and their opposite.
Good. It's a number like 5. It's a whole number. It's not 5 point something or 5.5. It's a whole number, the number 5. Or its opposite. All whole numbers and their opposite. So what's the opposite of 5? Abby? Negative 5. Negative 3 is an integer. What's its opposite? Jen? 3. 3 is the opposite of negative 3. Negative 5 is the opposite of 5. These are all integers because they're whole numbers or negative whole numbers. Okay? Fractions and mixed numbers are all rational numbers. So this mixed number can be written as a fraction. How do you get 7/4? If you're starting with 1 3/4, how do you get 7/4? How do you convert that, Ariana?
Do 1 times 4 plus 3.
Good. 1 times 4 plus 3. Good. And this is how you would write this in this form. A over B. In your book it says rational numbers can be written as a fraction A over B. And that's just saying a whole number over another whole number. When you're writing rational numbers, you have to write them as a whole number over another whole number. Okay? You can't write them as a half of a number or a tenth of a number. It has to be a whole number. All of these are written as whole numbers. So 0.5 is written as what? 5 tenths or 1/2. Okay? You can't write 0.5 over 1 to write 5 tenths as a rational number. Okay? Why not? Is 0.5 a whole number?
No.
No, you have to write it as a whole number over a whole number. Okay? So, 4, how do you read this number? 4 and what? Daria?
4 and 363,000.
Good. 4 and 363 thousandths. And so that's how you write it. 4 and 363 thousandths. But then since this 4 is a whole number, you can put that on the line. And it's 4,363 thousandths. That's a top-heavy fraction, isn't it? Is that okay to write it as a top-heavy fraction?
Yeah.
Yeah. Yeah, that's just fine. We wrote this as 7/4. That's a top-heavy fraction.
Yeah.
Okay? So these are all examples of what, class?
Rational.
Rational
Numbers.
numbers. Rational numbers. Rational numbers can be written as a fraction, or another word for fraction is ratio, as a ratio of A over B. Whole number over another whole number. So, on your worksheet, number 1, negative 10 can be written as, Lindsay? Negative 10 over 1. 51 hundredths can be written as, Bryce?
51 over 100.
51 over 100. Negative 1 and 1/3 can be written as 4/3. Close.
Negative 4/3.
Negative 4/3. And negative 3 and 10 hundredths can be written as, this is negative 3 and 10 hundredths. Could we reduce that first? What's 10 hundredths? 1/10. So first, let's reduce it to negative 3 and 1/10. Then what? How can you write this as a rational number then? Or as a ratio?
31 over 10.
Good.
Negative.
Negative 31 over 10. Very good. Okay? Now, one of the things you're asked to do is to find numbers on a number line. And they give you this example. 1.5, 2, and so on, right? Now, when you're filling in the rational numbers, how do you know what's in between them? Brett?
You can count, well, like, since it's 1.5, the next number would be 1.6.
Okay, so in this case, we can just figure it out. You can kind of guess 1.6, 1.7, 1.8, 1.9, right?
Yep.
Otherwise, there's a method that you can use. And you could do that this is, the difference is 0.5, because 2 minus 1.5 is 0.5, right? And since there are 5 segments between them, 1, 2, 3, 4, 5, if we divide this by 5, then you know each one is worth 0.1. Okay? So then you can add plus 0.1, plus 0.1, plus 0.1, and you can figure it out. What about the next section? Finding a number between. Let me ask you a question. Are there any numbers between 1.5 and 1.6?
Yes.
1.52.
Very good. If you put a 0 on here, then you can see, well, there's 1.51 and 1.52 and 1.53 and 1.54. And you can keep getting smaller and smaller. You could figure out what's between 1.51 and 1.52.
1.511.
How would you figure that out?
Add a 0.
Again, put a 0 on the end. So now this is 510 and 520. Well, 511 comes after 510. See? So 1.511 comes after 1.510. Right? Does that make sense?
Yep.
Do you see 1.510, Daria?
Yeah.
What comes after 1.510? 1.511. See, because 11 comes after 10. And so if we put a 0 on the end, we can find the next number, in this case, the next 1,000 that comes after it. Okay? How about in between fractions? Look at number 12. How could you find numbers in between fractions? Fractions are -3/10 and -1/3. Are there numbers between these?
Yeah.
Yeah. What would be an easy way to figure it out? What form could we change them to figure it out more easily?
You can make them into a decimal.
Yeah. Is this equal?
Yeah.
-3/10? -3/10. What comes after -3/10? What would this be? This would be -3/10. Repeating,
Oh, yeah.
right? Remember, 1/3 is 3/10 repeating. That's one that you should memorize. How do you figure that out? You do 1 divided by 3. Remember, the top number goes on the inside when you're converting a fraction to a decimal. And then you put a 0, and then 3 goes into 10 3 times, and you have a remainder of 1, and you bring down another 0, and 3 goes into 10 3 times, and I can do this until I die. Yeah, I'd have to have a, yeah. But this is a repeating decimal, isn't it? Right? So, this is 0.033333. And this is -0.30. So look at these two numbers. What comes in between them?
Two.
30 and 33. What comes in between them?
32.
And what else?
32.
And right? Because this is 333, so 330 would come before this, and so on and so on and so on, right? The cool thing about numbers, they just keep going and going and going. Okay? All right, finish this worksheet for tomorrow.
How did we discover numbers?
That's an awesome question. Where did numbers come from?
Jesus.
God.
Seriously? What?
God.
Yeah.
The distance of
The Greeks.
stuff.
I told you.
Yep.
Curious humans.
They're really from the mind of God.
That's a big
Yeah.